Hi, everybody. My name is Patrick Chanezon, and I'm not going to destroy any guitar on stage today, but that's the spirit. So the talk is called Never Mind the Bollocks. Here's the Linux containers. And it's kind of a joke based on the theme of that conference. They had some Sex Pistols images on the conference website, and I thought, hey, Linux containers, they're kind of wreaking havoc in the ecosystem right now about the tools that people are using to build apps. So that's pretty much what happened with the punk movement in the 70s. So a little bit about myself. I've been working at lots of different companies. Essentially, I spent 10 years building platforms and then 10 years evangelizing platform. I spent most of my career competing with Microsoft, and then 2 years ago, I joined Microsoft. So a lot of the examples you'll see here are on Azure. And I left Microsoft 3 months ago to join a new startup called Docker that builds the Docker product. I'm based in San Francisco, and I'm French. And one of the reasons I joined Docker, I was super happy at Microsoft, but I had the opportunity to go work with Solomon Hykes, the founder of Docker, on the future of the platform. And when I started using Docker pretty early on, essentially to run Java workloads on Azure, because in Azure you have Azure VMs, you have Azure websites. Both of them have some options for Java, but if you're used to Linux, it's not great. And containers on Linux VMs on Azure were a really good option for deployment, so I started playing with CoreOS, and then with Docker itself to package my Spring applications and deploy them on Azure. And then I started to play with lots of the orchestration tools, and very quickly my role at Microsoft became to bring the Docker ecosystem on Azure. And I'll tell you a little bit about the Docker ecosystem. It's pretty large. The feeling I had when I started using Docker is really the same feeling I had in 1995 when I discovered the browser for the first time. I was building client-server application at that time, and when I started using the browser, I realized, hey, there are lots of apps that we're building that we could build as web apps. And then I spent the next 20 years building web apps. I think with Docker and microservices, it's the same kind of feeling. It's really changing the way you're building applications. And there's really a qualitative change that's linked to quantities. And the quantities here are the speed of a start of a container compared to a VM. Typically, when you make things 10 times faster, you start using them more and more, and then your workflow changes. So that's kind of the idea there. So I modeled my talk after the Sex Pistols songs. Before I get started, I'd like to know who here has used Docker already? Okay, so a good part of the audience. So I won't go in the basics in there, or I'll skip there to go to the more advanced examples. Who's a Java developer? Okay, nearly everybody, excellent. .NET developers, maybe? Okay, very good. So .NET support for Docker, Microsoft is working on that. But today, if you're building ASP.NET applications, you can already deploy them on Linux containers. So, holidays in the sun, the history of containers, containers are not a new notion, they've been existing for a long time. Isolation or operating system virtualization, it existed in mainframes. In the 90s, we had hardware virtualization, but to me, the real precursors are BSD jails and Solaris containers. So Solaris containers existed around 2005 already, so it's like 10 years old. In 2006, there was Cloud IaaS with Amazon EC2, and then Google came up with the platform as a service notion with Google App Engine. And in 2013, what Docker did is to make containers accessible. Containers were kind of hard to use and configure. Docker is kind of a nice command line tool that lets you create these containers in an easy way. So the analogy with containers is that you're packaging all your application and its dependencies into that unit that can be moved around, so it gives you portability. And that's one of the reasons why Docker has been very successful. So in the past, the project is only 2 years old, but there's been hundreds of millions of images downloaded already. And actually, this is an old slide. I should update it. We celebrated the birthday of Docker, the 2 years birthday, just when I started, like 3 months ago. So it's a pretty recent project, but that's really took the industry by storm and changed everything. So write once, run everywhere. That's kind of the promise of Docker. Many of you will recognize that from the Sun marketing from the 90s. I think with Java, we got some level of portability. It was pretty good. You can run Java applications on Windows, Linux, and Solaris. I think Docker goes a bit further because it's not limited to Java applications. It applies to all your applications. So why is it successful now? I think there's a conjunction of factors. First, cloud adoption. Enterprises, after rejecting public cloud for quite a while, many years, and I've been there. I tried to sell Google Cloud in enterprises like in 2008 or something like that, and they were really not ready to adopt it. This year, like in 2015, lots of enterprises are starting to adopt public cloud. And when they adopt public cloud, they want to avoid the lock-in that came with previous platforms, and so they want portability. They want to create hybrid clouds with some of their workloads running inside the firewall, some outside. And Docker gives them that, and they are adopting a DevOps approach where Dev and Ops are working together. Docker enables that, all these capabilities. That's a view of the cloud market that I use with my team at Microsoft. I explained them the simplistic view that I have about the cloud market, and using movie analogies. So the big buckets there are basically 4 big players plus Docker that kind of change the whole equation. On the left side, you have private cloud, and VMware is very strong in there. But they have a problem. They don't have a good hybrid strategy, so they're trying to do vCloud Air. It doesn't get much traction, so they don't have that public cloud experience that you have when you're running data centers all around the world with thousands of machines in there. And so VMware, very strong in private cloud, but have an issue with a hybrid strategy. I compare them to 300. I don't know if you remember the movie. They're very courageous, they're strong, they shout Sparta, but we all know how they end in the end. Yeah. I used to be at VMware, so Google. When I was at Google, I tried to sell App Engine for Business, which was a version of App Engine that we built, like a version of Platform as a Service that we built specially for enterprises. And when I went to see CIOs and discuss with them, basically they laughed at me and they said, hey, we want hybrid and open source. Your Platform as a Service doesn't give me the level of control. I cannot do hybrid with it. And I really had the feeling that I was like that character Marty in Back to the Future. I don't know if you remember that movie. It's an adolescent from the 80s who goes back in time in the 50s where they don't know rock and roll yet. And he comes on stage and he starts playing hard rock to them, and they are baffled. The audience is silent and it just doesn't work at all. They don't understand that music from the future. And to me, Google is very much like that. They paint a picture and they build systems that are from the future, but they don't give customers a path to adopt them. And so I compare them to Back to the Future. Amazon, it's like Pacific Rim, especially for enterprise players. They used to sell books. They invented the cloud market, and for enterprise companies like VMware and Microsoft, they're like these big monsters in Pacific Rim who come out of nowhere from a fault under the Pacific Ocean and invade the enterprise market. So when I was at Microsoft, my motto was, we need to send them back where they come from, like in the movie. And Microsoft, to me, is field of dreams. Build it and they will come. Microsoft always had a strong hybrid strategy. They're really in between. So they have a strong public cloud with Azure, and then they have It used to be called Azure Pack. I think they have a new name for maybe Azure Stack now. So it's a version of Azure that you can install in your data center to build your cloud. So the market was kind of set like that 2 years ago, and then Docker appeared. And it was set with infrastructure as a service and platform as a service as kind of the two big categories. And Docker introduced something in between with containers, and the whole market is reorganizing itself around that. And there's a whole ecosystem around Docker. So that's how I see the ecosystem reorganizing itself. So at the bottom, you have the new hardware. So that's VMware, Giant, Microsoft, Amazon, and Google. The cloud providers provide the resources, hardware, software, and networking and storage on which your workloads are going to run. So that's the new hardware layer. On top of that, you have a new type of operating system that are shrunk versions of the classic operating systems, both Linux and Windows, that are just designed with a kernel and a Docker daemon. They are designed to run Docker workloads. So CoreOS started this trend, and then very inspired by the way distributions are built at Google in the data center. And then very quickly they were followed by the Project Atomic from Red Hat. VMware has Photon. Ubuntu has Ubuntu Core. The most interesting to me is RunShareOS. RunShareOS went one step further. They just have the kernel and 2 Docker daemons. They don't even have like other system daemons like etcd and systemd. And what they do is that they run system daemons in a privileged Docker daemon just for the system, and then you have your userland Docker daemon for your regular tasks. Then you have add-ons. What you see on the left there, Weave Networks and Flocker. They're building add-ons to Docker. So Weave is building an overlay network for your containers, and Flocker provides a way to move your stateful containers from one host to another. But then the big battle happens on the right there, which is orchestration. So I'll talk in more details about that, but that's where there are lots of innovation. There are new orchestration engines coming up every 2 weeks. I have 2 more that I heard about in the past few days that I should add to these slides. So the big contenders there are Docker Swarm from Docker. There's Apache Mesos, which is pretty mature and has lots of features. There's Kubernetes from Google, which is an open source orchestration engine inspired by Borg that they run internally. Deis is inspired by, it's another open source framework, and it's inspired by Heroku. It gives you a Docker-based Heroku for any cloud. Cloud Foundry, which was a platform as a service, reinvented itself as an orchestration engine with Project Lattice and Diego. IBM Bluemix is based on Cloud Foundry. It's a platform as a service, but they have a Docker service in addition to that. Apprenda added Docker support recently, and Tutum is a SaaS platform, a SaaS-based orchestration engine where you bring your own resources, like virtual machines from your different clouds, and it orchestrates the containers on that. So, no feelings. Docker is about isolation. And that, I should add a picture there. So that's supposed to be Sid Vicious, but to me that's Solomon Hykes when he created Docker to help you isolate your workloads. So what Docker is, essentially, it's operating system level virtualization, where instead of running a hypervisor and a copy of the guest OS for each of the VMs that you're running, there you share the host OS, and Docker Engine just lets you use native capabilities of the OS for isolation, namespaces, and cgroups, and it assembles these namespaces and cgroups and run your processes isolated in there. So each process thinks it has its own network stack, its own root file system, and its own PID, and all that. So the namespaces that are used in Docker, PID, MNT, net, UTS, IPC, and user is not in there. The user namespace, I think that's planned for next release. cgroups let you control memory, CPU for the containers that you're launching, and access to devices. And so what is Docker now? So Docker is a platform to build, ship, and run applications and run them anywhere. And it's composed of a bunch of different projects. So there's Docker Engine itself, Docker Hub, where you store your images, and that's kind of essential in the workflow when you're building containers. Docker Machine to provision machines that have the Docker Engine pre-installed on any cloud. Docker Compose to compose your application of different microservices. Swarm for clustering, and Kitematic, which is a UI for Docker. So when you're a developer and you get started with your Docker project, you start with an image, you build an image. And in order to build an image, you can build it manually with a Docker command line, or you can use what is called a Docker file, which is a very simple declarative format for specifying how you want your image to be built. So typically, you inherit from an existing base image. So for Java, there's a base image called Java. You can specify the version, 7 or 8. Then you copy your code. So here, copy will copy my code into a specific directory inside of the container. I specify a working directory. I can compile my code in there, and I can specify a command that will be launched when I launch that container. Then when I'm done with that, I can build my image with a Docker build and then run it with Docker run. Once I have built several containers for different microservices for my app, and there are containers for databases as well, for Mongo, MySQL. There's a Couchbase image that came up pretty recently. I gave a talk at the Couch conference the other day with a demo application. You can find that on my slide share. Typically, you would assemble what is called a compose file, which is another declarative syntax, pretty simple, where you declare the various containers that your app is built on, and then when you do a Docker compose up in the directory where that file is, it's going to read that file, create all the containers for you, and give you access to the logs. So that's super convenient for development. So here is an example for a simple Python application where I'm going to launch the command python app.py, open the ports 5000, map them to 5000. I'm going to mount a volume in where my code is right now. I'm going to mount it as a volume in /code in the container. And then I'm going to create a link. So the links instructions creates a link between the container running my web app and the Redis container. And then the next step, I have a Redis container where I just run Redis. And what that link does is that it adds an entry in etc host for the container that's running my web app, where it gives the IP address of the other container and creates the routing table so that the two containers can talk to each other. Docker Machine is pretty powerful. It's a utility that lets you create, when you start playing with Docker, you install Docker on your laptop, you create your Docker file, you play with it, you create your compose file, you build your application. When you're ready, maybe you want to create a small cluster of machines in Azure or DigitalOcean or Amazon to test your app, and then you want to deploy it to production. Docker Machine lets you create provision machines with the Docker engine installed on them on any of these cloud providers. So there's a driver system. There are drivers for most of the big cloud providers as well as virtualization providers for your laptop. So you can provision images on VMware, VirtualBox, Hyper-V as well on Windows. And then Azure, Amazon, and all the other cloud providers. So typically, when you run Docker Machine, you do a create, you pass -d, the name of the driver, and then there are some driver-specific parameters. For example, in Azure, you need your subscription ID and your certs and all that, which region, which type of machine I want. Then I specify a name, and the convenience that machine gives you is that machine stores all your certificates locally, and then there's a command in Docker Machine to say, generate the environment variable to run Docker targeting this machine. And so you can switch machine pretty easily. It happened to me pretty often to deploy something that I thought, I'm on localhost, but no, I had changed my environment and I'm actually deploying to Azure. Docker Hub is where you store your images. And so that's the Couchbase image that came out recently. So typically when when you need a service, you need Mongo or you need Couch, you just do a quick lookup on Docker Hub, and you can see images, either the official images. For most of the open source projects, they are official images. But there are also developers who build some interesting images with lots of different things in them. And typically in the new projects that are kind of cutting edge, you find images, and images are rated, and so they are shown to you in the order in which they have been rated. And so the highly rated images, you can find some really interesting stuff in there. So Docker Hub, when you create your own images, if you're building an enterprise application, typically you don't want to put your images in public. So the hub by default makes your images public, and you can create an account for free over there. But we have a subscription option where if you buy a subscription, you can have a certain number of private repositories that you can create. And we also have a version that's called Docker Hub Enterprise that you can install behind the firewall to have your teams collaborate on private images. So that's Docker Hub Enterprise. And that's our business model. And then Kitematic, it's a UI tool for Macs, and they're working on a Windows version now that lets you use Docker, and it's pretty convenient, and it's integrated with Hub. You can look up images. I'll show you a demo afterwards. It's pretty cool. So you can deploy anywhere. When I mean anywhere, Docker started as a technology just dedicated to Linux. What's happening right now is that Microsoft liked the technology so much that they bet the farm on it, and what they did is that they are implementing the Docker engine in terms of Windows primitives. So the isolation primitives of namespaces and cgroups that are Linux specific, Microsoft is building the same kind of primitives in the next version of Windows Server that will be called Nano Server. It's like CoreOS. It's a small version of Windows without any UI. It's only command line. It's designed for the data center that just has these new isolation primitives and is running a version of Docker Engine that Microsoft built. They built a backend for Docker Engine implementing in terms of Windows. And that Mark Rusinovich gave a demo of that at the Build conference 1 month ago. And that should ship in early access with the next version of Windows Server. I think they have an early access in August or something like that. So what that means is that in August, you'll be able to run .NET applications native to Windows running in containers, in Windows containers on Windows Server. What that means as well is on the ops side, you can use the Docker client to manage both Linux workloads and Windows workloads. It's the same API. So Docker is an open source project. There's a big community. We're a company. The company is still a startup. We're 130 employees based in San Francisco. Yeah. And problems. What kind of problem does Docker solve? And I'd say one of the main problems is that fight that happens since many years between devs and ops. So in the client-server era, the relationship between dev and ops was not great, and automation on the client side was not perfect. During the web era, I remember when I was at Netscape, we developers were creating our application, send it to ops, and they needed to, if there were some issues in production, it was never our fault. So the relationship was not much better. And what's happening right now is that after Agile took off and took like 10 years to take off in 2000 to 2010, like most companies are doing some form of Agile. DevOps to me is the next step of that, where these agile methodologies where you're using common tools and you iterate very quickly and you create that feedback loop between your code and your users, it just transferred to ops. And so now dev and ops are working with the same tools, and Docker enables that workflow. It's a good abstraction layer for building an artifact where on the dev side, I build everything that's inside the container with my code, my libraries, package management, all my application and data. And then on the upside, they take the container typically from a hub, whether enterprise or private or public, and then they configure logging and remote access and network configuration, monitoring, and all that. So, Anarchy in the UK, that was my favorite song on that album, and that's my favorite topic as well, which is orchestration. As I told you, the landscape for orchestration is pretty complicated, and what's been happening over the last year is that in lots of companies, developers starting building microservices apps based on Docker, and then they went to their ops, they deployed them on cloud platforms like Amazon or Azure, and then they go to their ops and they say, we'd like to push that to production. And the next question that comes up is, what should we use to orchestrate this? And I'd say this is an area that's still like full. There's lots of innovation in that space. There's lots of confusion as well. So for both developers and ops looking into that space, you can spend hours looking into this. What I'm trying here is to give you an idea of a feel for the capabilities of the various orchestration platforms, at least the main ones. So Docker Swarm is the one that's built by Docker. And at Docker, we try to make things really simple. And so with Swarm, we kept that goal of minimalism and keeping it simple. So when you're using the command line and you're talking to a Docker engine, typically you configure environment variables or config parameters that you pass to the command line to say, talk to that engine, and then your session is about talking to just one engine. So when you want to schedule containers on different engines, you need to talk to each of them separately. And that's typically what people have been doing with lots of shell scripts, and some ugly and some not so ugly. Docker Swarm, what it's doing is that it's putting a front end in front of all these engines. So Swarm is a daemon that talks to all these engines, has an idea about their characteristics, and then with your Docker client, you're talking to Swarm, and you tell it, hey, please deploy a container, or list me your containers, and Swarm will just do the orchestration for you. It will deploy it on a host where there's some room, and there's a set of features where you can specify affinities, you can specify some constraints for how your containers are going to deploy, and Swarm takes care of all that. The beauty of Swarm is that it's using the same API as Docker, so there's no additional APIs to it. Your client talks to it using the Docker API, and then you pass your affinities as environment variables, and you can pass things like resource management. There are lots of options in there. It's partially integrated with Compose. I'll show you a demo of that. It's fully integrated with machine. I'll show you that as well. That's really cool, which means when you want to provision a Swarm cluster, there are just some options in machine where you say, this machine that I provision is going to be the master, and then all these machines are going to be nodes. And there's a nice integration with Mesos as well. One of the things that Swarm doesn't do is load balancing. So it's left as an exercise to the reader. Hopefully, there's an open source project called Interlock by Ivan Hazlett, who's from the Docker team, that provides that. The way it works is the Swarm daemon generates a bunch of events. Every time you start a container, there's an event that's generated. What Interlock is doing is it's a daemon that you launch. The daemon listens to the events from the Swarm cluster. Every time there's an event, it reads the configuration from the various containers that have been launched in there, and then it generates. Interlock has a set of plugins. There's one for HAProxy and one for Nginx, and then it configures HAProxy to do load balancing for containers that have been launched with the same host name. So it doesn't take care of DNS. You have to do that out of band, but still, it's a great way to do load balancing, and it's a pretty elegant design. Mesos is more mature, I would say. It's been developed at Twitter. It's used in production at places like Netflix, and it's a cluster management system that's really designed to manage clusters of tens of thousands of machines. And the way it works is that the Mesos master will have a bunch of slaves that it manages for resources, and then it talks to what is called framework in Mesos parlance, and the master is going to make some offers to frameworks. And so the classic framework they have is called Marathon. So there are some APIs to build a Marathon application. And so Mesos has been used to deploy Hadoop clusters or clusters of Java applications. Now we're doing an integration with them with what is called we're building, or they're building actually, a swarm framework, which means that you can launch a Docker Swarm daemon that's going to, instead of talking to a lot of Docker engines directly, is going to receive offers from a Mesos master, and the offers will be, hey, there's some room on these various Mesos slaves that have Docker daemon installed. And then it's going to schedule its containers using the offers. So that's something that will be demoed at DockerCon in 2 days, I think, on Monday. Then there's DS. So DS went through a bunch of changes. The goal of DS is to provide you, it's more fully featured than the other ones. So Mesos is still pretty low level. DS is kind of focused on the developer workflow, and they want to give you the Heroku developer workflow, where you do a git push of your code and it takes care of everything. It does the routing for you and all that. It's a pretty complex project. There are lots of services in there. DS is using Swarm as its orchestration engine internally. And then it's more fully featured in that there's a router mesh in there. It takes care of load balancing for you. So it does a little bit more for you. In my experience, but that was a few months ago when I tried to install it on Azure, it was a little bit less mature than the other ones. But still, the developer workflow is really nice. Then there's Kubernetes. So Kubernetes from Google, it has a few more concepts than Docker itself. So they have this notion of pods where you have several containers, you put them together into what is called a pod, and the semantics of isolation is slightly different, where inside of a pod, all the containers are running in their own file system, but they share volumes. So volumes are shared among all the containers in a single pod. And I think they share the PID namespace, which means that they can do inter-process communication between them. And they share the network. So each pod has a unique IP address assigned to it. So the unit of orchestration is not the container, it's the pod. So you assemble a pod, there's a YAML definition file for that, and then that's what you're going to schedule. Then, in terms of scheduling your pods, the way you do that is that you use replication controllers. So you have one level of indirection where you can say, this is my pod, please replicate it to 10 or 15 different instances. And that will be taken care of by the replication controller, who monitors all the pods and makes sure that there are always a certain number of them available. And then in addition to that, they have this notion of labels that have been added in Docker since then. So you can label your pods, and based on label, you have this notion of service. And service is the piece that's going to do the load balancing. So you can say, all the pods that are associated to that label, please load balance them at that URL. So I'd say Kubernetes is slightly more fully featured than Docker Swarm because it does the load balancing for you. It's slightly more involved to set up as well because you need to set up an overlay network with it. I participated into documenting how to install it on Azure at the time. I was using Weave. There's another option which is using Flannel with CoreOS. So slightly more involved to set up, a little bit more fully featured, a bit more concepts in there. Then there's Cloud Foundry, which is a big beast that was designed as a platform, as a service, and they gave it. The Cloud Foundry team really understood that now people didn't want only the Heroku workflow of pushing their code and having some restricted frameworks in build packs to deploy, but that they wanted to deploy containers where they would specify what they wanted in there. And so they created that project called Lattice, which is a subset of Cloud Foundry where they just kept the logging system, the router, and the Diego container orchestration engine that they have. And so Lattice is really designed to be a container orchestration engine. Now, the thing is, Cloud Foundry, they have their own isolation technology that's called Garden, so they don't use Docker natively, but if you specify a Docker image, they're going to pull the image and transform it into something that Garden can run. There was Julian from IBM gave a talk at Cloud Foundry Summit, if you can find the video, where he implemented a Garden backend in terms of the Docker engine. So all these technologies are kind of converging and trying to understand where their boundaries are. IBM is in an interesting situation where they really bet the farm on open source, and so their offering is based on OpenStack at the bottom layer. Then there's Cloud Foundry for orchestration, and they added a native Docker container support recently. And then there's Tutum. Tutum is an interesting one. They're doing orchestration, but they're a software as a service. So it's a service, you sign up for it, you go to their website, and there you can start adding your VMs from Amazon, from Google, from Azure, and they're going to install Docker Engine on it, and then when you schedule containers, they're going to schedule them for you and do the load balancing and all that. So they have a bunch of services for continuous integration, load balancing. It's an interesting platform. All right, let's talk just a little bit about the plugin ecosystem around Docker. So Docker is built in Go, and up to now there was no plugin system for it. However, Docker doesn't do everything. There are a bunch of things like when you want to do virtual networking for your containers, or if you want to move a container, a stateful container from one machine to another, you could have third-party software that could help you with that. So Flocker is such a software. They built this system called Flocker that's based on ZFS that helps you move a stateful container from one host to another. When you're running your MongoDB or MySQL database in a container, if your orchestration engine chooses to move it from one node to another, Flocker is the one that's doing the job. And the way they do that is with some kind of two-phase commit using ZFS, where when you ask the container to move, what they do is that they do a ZFS snapshot of the file system where the data is for your volume. Then they start moving all that to the other host, and that can take several hours. So your container continues to run during that time. And once it's done, it tells the container, OK, you can stop. And then your container stops. It does a ZFS diff, a diff of the between the snapshot and what's been happening while the container was running, moves the diff over there, and then restarts your container on the other side. So that's Flocker. The other one is Weave. So Weave provides virtual networking for containers as well as a DNS service. So what that means is that when you're launching your containers, Weave assigns IP addresses to them in the same subnet, while these containers, some of them may be on Azure, others on Amazon or on your local machine, and it can also assign DNS names to it. So it's really convenient for development and to understand what's happening between containers. The problem with both Weave and Flocker is that up to recently, there was no plugin system in Docker, and so they relied on a hack, something called PowerStrip, where they injected a proxy between the Docker client and the server. So the Docker client and server are talking a REST API with a JSON payload. What they're doing is that they intercept the JSON payload, and they say, oh, before you do stop for a container, please call Weave for IP address management and call Flocker for moving the volume. And they have posthook for finishing the work. So that works, but it doesn't work in production because if your Docker engine restarts and restarts all the containers, PowerStrip won't be in the loop there. And so we've been working with both Flocker and Weave on a Docker plugin system with well-defined extension points for both volumes and networking that will be announced at DockerCon. So we'll do a demo of that on Monday at DockerCon of how Flocker and Weave work with the new plugin system. If you want to play with that, it's available in the experimental build of Docker 1.7 in the nightly builds. All right, so that's all for the presentation. Now I'm going to show you a few demos of what that means. So first, the application I'm using, so I hope many of you have been at the Josh session. So Josh Long and I used to work together. And so recently, like 6 months ago, he built this pretty cool app that's called Spring Doggy. And I'm using that as a demo for most of my applications. So it's a modern Spring Boot application with a very nice JavaScript front end. It's using MongoDB and MongoFS in the back end. And what the app is doing is that you upload an image and it just adds a bunch of stuff to the image. So when I saw his application, I liked it, and I said, let's use that as a sample application for deploying Docker containers on Azure. And I built a Docker file for it. So that's what the Docker file looks like. So I built that a while ago. I didn't know about the Java images. Now I would do from Java 8, I guess. Also, what I'm doing here is that I'm using this image where Java 8 and Maven are installed, and so I'm using the image to compile it, to compile the code. In a more realistic workflow, you would have your code does a git push, then you go to a Jenkins workflow. Jenkins has released a bunch of new Docker integration plugins. So Jenkins would just build your code and create the image, and then you would and push it to Docker Hub or to Docker Hub Enterprise, and then you would use that to run as an artifact. But this is an example. So here I'm exposing port 8080. The work dir inside of the container is local git. In there, I'm doing a git clone of the code base, which is the Java app. And then I do a Maven package of that application. And the command line that I launch when I launch the app is a java -jar to the jar that has been built. And I pass as a parameter MongoDB URI environment variable that's going to be my connection string for Mongo. So that's the Spring Doge application. Now, Now, when I run that on my local machine, typically in Azure, I would use a Mongo Labs instance that I have provisioned out of band. But here, we have a Mongo image. So what I'm going to do is I created a compose file for this, where I say the image that I use is the one that I pushed to. So I built that image, and I pushed it to Docker Hub. So it's Chanezon Spring Dog. Then I expose, I'm mapping port 8090 to 8080 because I was running something else that day. And then I create a link to Mongo, and I'm going to run the Mongo image that's going to generate. So that means that Mongo image here, it means it's going to run a MongoDB database, and it's going to be linked as Mongo, as a host name. And so I can pass the environment variable MongoDB URI to Mongo on that port. And when I'm done with that, I can do, I don't know if boot to Docker is started yet. Oops. So I'm going to start boot to Docker, which is the way you run Docker on a Mac. So Docker is Linux. So on a Mac, the way you work is you install something that's called boot to Docker. That's a Linux distribution, small one, running in VirtualBox with Docker pre-installed on it. And then your Docker client on the Mac is talking to that Linux host locally. So here, when I run boot to Docker, you see the environment variables that I'm going to use to target it. So when I do a Docker PS, let's see, I don't have anything running in there. And so if I do Docker compose up, in there, it's going to create the Mongo database, like launch the Mongo daemon, and then launch the Spring application, and launch the Spring, and then I can do a boot to Docker IP to see what IP address my VirtualBox instance has. And so here I can see the logs of my application. It seems it has started. I think I mapped 8090. So if I go there, I should have my application. Okay, so my application is running. And I'll just show you. So there's a nice monitoring page in there that shows all the uploads. And what the application is doing is, I'm just going to take a desktop, one of the images on my desktop, like never mind the bollocks. You drag and drop it there, and there's a nice like animation. It shows you all the images that are uploaded to it, and the images are like modified. There's a bunch of text that's added to them, and they're stored in MongoFS in the backend. And so when I'm in development, I don't need to have anything installed in there. Actually, I could rebuild the image, and instead of targeting GitHub, I could target my local directory, and I could have the image building process build my Java code as well. So that's running Spring Doggy in Docker Compose. Another thing I wanted to show you is Kitematic. So let's look at that same application. So Kitematic is integrated with Docker Hub. Oh, so what's it's integrated, but there seems to be a networking issue here. So I'm just going to show you some images I have running already. So this is a Minecraft image. So you find images in there, and you can say, hey, please start my server there. And it's going to start my container, show me the logs. I can see the logs there by clicking on that, so I can see the logs in real time. I can do, in settings, I can specify things that I would specify on the command line in the Docker command line. So I can set variables, I can set the ports, I can map volumes. And then when I go back to the home directory here, I see the data volumes that are linked to that. And so Minecraft, it's not maybe a good example, but for Nginx, let's start an Nginx here. I can go to website files, and I can edit that directly from here. All right, I have too many editors in there. No, I don't want to launch that in Notepad. All right. Devox, UK. So I save that, and if I go in, if I click there, so that's a very easy way to get started working with containers that have been packaged for you, and you can go directly into the volumes that have been mounted to these containers. One of the things that people love with that as well is that it launches a terminal for you inside of the container. Oops. So here, I just launched a terminal. It's actually launched a terminal inside of the container that's running Nginx, so you can see I see only what's in there. The last thing so I have only 4 minutes left. The last thing I wanted to show you is an app that I've been building in the past few days. It's a simple, or let me show you the code. So I told you about interlock. When I talked with Arun before coming here, he told me it would be nice to be able to see all my swarm nodes in my cluster and see the containers that are running in them. Actually, I just built that application this week. So it's a simple Node.js application that's using, let me show you the code. It's like, like 80 lines of code, and there's a bunch of JavaScript for the visualization on the client side. So it's a Node application that's using a library called, how is it called? It's called it's called, I forgot how it's called. Socket.io, Express, Static, new Docker. Yeah, so there's a Node module. Oh yeah, it's called Docker Node. So the Docker Node module implements all the Docker API in JavaScript, and so I'm just using that. I'm talking to Swarm, and I ask for it, give me all the containers that you're running, and when Swarm answers, it gives you the name of the Swarm node where it's running. And so what this code is doing is that it's getting all these, assembling a list of containers with first the name of there's first the name of the node, and then the list of containers. And then I pass that into a D3.js-based visualization. Let's see if it's still working. So here it's connecting to, so it's running on port 3000. So if I go there, I call it Swarm Console. Yeah, so that's what it is. And let me show you what it looks like. So it's getting this kind of, so this is kind of the simplified version. I get rid of all the details coming from the Docker inspect that I'm doing in there. I just keep the name of the container and the name of the image. In the future, I may add some more stuff to that. And so what the result is you can see that I have in my Swarm cluster, I have 2 machines that are running 26 containers. And I can just go in there where I think I have, yeah. I can, for example, add 10 more containers to that. So I'm going to schedule 10 more containers on that Swarm cluster. And if I go there, you'll see them appearing as they are scheduled, if everything works as planned. Let me see where. So it is scheduling them. No, it still hasn't retrieved them. But there's already like 4 or 6 of them that have been, oh, time's up. Let me show you one last thing before, 29. So they are appearing slowly. I should provision bigger machines. The last thing I wanted to show is I wanted to show that you could do that with a large cluster. And so I just, here on the client side, when I say multiply equal true, I just multiply the number of hosts by 10 and the number of containers by 50. And so that's what visualization of a large cluster would look like. So here I have 50 nodes and 15,000 containers. So I still need to provision like some big G instances on Azure and test this puppy to see if it scales well. And I also want to add some way to, when you hover over the containers, to get all the details about them. The next step would be to add the way to act on them. So that's where I'm at right now. Okay, time's up. Do you have any questions? Do we have time for questions? Not really? Okay. So I'll be out. If you have any questions, I'll just be out in the room, and I'm really happy to answer any questions or show you some other demos. Thanks very much.